B. The discriminant of a quadratic equation. Recall from last year that the discriminant is the part underneath the square root of the quadratic formula. Or we could say the discriminant with the symbol of triangle is equal to b squared minus 4ac. So discriminant equals b squared minus 4ac. What do we know about the discriminant? If the discriminant is equal to 0, it has one solution, and it is a repeated solution. And the solution is x equals negative b over 2a. Also remember that is the equation that we learned last year to represent the x value of the vertex, and that entire equation is the axis of symmetry for our quadratic graph. If the discriminant is greater than 0, we have two distinct real roots. And those answers can be found by taking negative b plus or minus the square root of the discriminant divided by 2a. If the discriminant is less than 0, we have the square root of a negative number, which is no real solutions. Instead, we have two imaginary or complex solutions. Remember, solutions and roots are the same thing. Our last situation, if our a, b, and c happen to be rational numbers can be written as fractions, and the discriminant is a square, then the equation has two rational roots. And you can solve this type of equation by factorization. Here's another way to work. Factorizing of quadratics. Two distinct linear roots. We have two real distinct roots. The discriminant is greater than 0. Two identical linear factors, a repeated root, the discriminant is equal to 0. And no real roots or two complex solutions, the discriminant is less than 0. Now let's look at what this means graphically. If the discriminant is positive, we have two real roots. On our graph, our roots are illustrated by our x-intercepts. So that means we will have two x-intercepts, or two real solutions, two real roots. If the discriminant is 0, we have one repeated root, which means that the root is equal to the vertex, or the x value of the vertex. So we have one x-intercept, and it is the vertex of our graph. If the discriminant is negative, we have no real roots, and we have two complex or imaginary roots. And that means that the graph will not ever touch the x-axis. This graphical knowledge to answer our first four examples. In the graph below, determine A, the sign of the discriminant, and B, the number of roots. So look at this. We don't cross the x-intercept at all, so our discriminant must be negative, less than 0, and we have two imaginary roots. Example 2, we have one x-intercept, so that means our determinant must be equal to 0, and we have one real solution or root. In number 3, we have two x-intercepts, so the discriminant must be greater than 0, and that means we have two real roots. Here we have one x-intercept, discriminant equals 0, and one real root. By using the discriminant only, state the nature of the roots for each example. So in our first equation, negative 10x squared minus 3x minus 9 equals negative 2x, we first want to get it equal to 0. We cannot find our discriminant until our equation is equal to 0 when combined like terms. Now we identify our a, our b, and our c term. Then we recall that the discriminant is b squared minus 4ac, so we substitute in the values for b squared and the 4ac. Simplify down, and we end up our discriminant is negative 359. So our nature of our roots is we have two imaginary solutions. We're going to do the same thing here. So first we need to get the equation equal to 0, combining like terms. In this case, we don't have any like terms. Identify our a, b, and a c. Discriminant is b squared minus 4ac. So we got negative 10 squared minus 4 times 2 times negative 5. Simplifying that down, we end up where our discriminant is equal to 140. Well, that's a positive number. Then we say, okay, is that a perfect square root? No, 140 is not a perfect square root. So we have two real irrational solutions. If the discriminant had been positive and a perfect square, we would have two real rationals. So that's the difference between irrational and rational roots. Our next example, we're going to still use the discriminant only, but this time we're going to find if they're rational roots so that it can be factorized. So we want only the factorization rational roots. So remember, that only occurs when the discriminant is greater than 0 and when our discriminant is a perfect radical square root, and that answer is a rational number, and when a, b, and c terms are also rational numbers. So there's three things we have to look at for this case. So first, as always, we must get it equal to 0, so I'm going to add the 3x to each side, combining like terms, identify my a, my b, and my c term. My a, my b, and c, and make sure that all three numbers are rational numbers. Then I'm going to find my discriminant, so that's going to be b squared minus 4ac, substituting in my values for b, a, and c, simplifying it down, and I find that I got my discriminant is equal to 0. Well, since the discriminant is not positive, I can stop my check there, and I know that no, I cannot solve this equation by factoring. Okay, let's look at our next example, example number A. We're going to do the same thing, so let's get it all equal to 0. So I'm going to add the 7x, add the 9, combine my like terms, and I'm going to identify my a term, my b term, my c term. Now look at those three numbers. Yes, they're all rational numbers, so it passed the first test. I'm going to find my discriminant by substituting in my a, my b, and my c values, simplifying that down. I find my discriminant is 121. So yes, that's positive. Now the square root of 121 is 11, so yes, that is a rational answer. So my answer is yes. This equation can be solved by factoring. Our next example, we're going to do a couple things. We're going to find a sign diagram of the discriminant. So let me explain what that is. First, you're going to identify your a, b, and c term. We're going to find our discriminant by using our formula b squared minus 4ac. And we're going to simplify down. This time we're going to have a variable in our discriminant. To find our sign diagram, the first thing you do is you take your discriminant and you set it equal to 0. Solve for the missing variable. So in this case, m would be equal to 1. So I'm going to make my discriminant sign diagram. I draw a number line, and I write on the number line the numbers in which m was equal to 0, and where our discriminant was equal to 0. So that's at 1. Now I want to choose some values on each side of that 1, plug it into my discriminant, and see if I get a positive discriminant or a negative discriminant. So when I try 0, I'll get positive. When I try 2, I get a negative solution. So what this graph tells me is anytime m is less than 1, my discriminant will be positive. Anytime m is 1, my discriminant is 0. Anytime m is greater than 1, my discriminant is negative. Discriminant sign diagram, let's answer part I. A repeated root, well, that occurs when our discriminant equals 0. Well, on our diagram, that occurs when m is 1. So our answer is when m equals 1. 2. Two distinct real roots. That's what happens when our discriminant is positive. Well, that's the blue part, so that occurs when m is less than 1. 3. No real roots. Well, I know that occurs when discriminant is less than 0, and that occurs when our negative, which is the green part, so that's when m is greater than 1. Example 10, we're going to also use our discriminant and sign diagram to find values of k for which we have the four following things. So again, we're going to start the same way. We need to get our equation equal to 0, so I'm going to subtract 1 from each side. Now notice that k plus 3 is considered a number. That's my b term. So identify my a, b, and c, substitute in the values into my discriminant equation. Simplify this equation down, multiplying our factors together, combining like terms, and we end up with our discriminant is equal to this. So let's try factoring this discriminant if possible. Well, it does factor to k plus 9 times k plus 1. And to find our discriminant sign diagram, remember we draw a number line and we need to put when our discriminant equals 0. So I'm going to set my discriminant equals 0, solve each of these factors using our null factor law. And I end up, our discriminant is 0 at negative 9 and negative 1. So I'm going to do some test points on each side of this. So something less than negative 9, I'm going to choose negative 10. And I don't really care what the number is, but I notice I get a positive value. Negative times negative, positive. Something in between, I'll try negative 5. First term is positive, second term is negative, so that gives me a negative overall. And then for our last one, now you might want to try 0, but you have to be careful. You can't use 0 because if k was 0, this first term, 0 times x squared eliminates the x squared term, and you no longer have a quadratic. So that's positive except when k is equal to 0. We have to put that as a notation. So now I'm going to use my distinct rational roots. So when I have two distinct rational is when my discriminant is greater than 0. So that occurs at two spots. When k is less than 9, or when k is greater than 1, but k cannot equal 0. Two real roots. Okay, that happens when k is greater than or equal to 0. So that's when k is less than or equal to negative 9, or k is greater than or equal to negative 1. Again, k cannot equal 0. 3, a repeated root. That occurs when our discriminant equals 0. That's when k equals negative 9 or k equals 1. And two imaginary roots, that's when our discriminant is less than 0. That occurs between the negative 9 and the negative 1. So negative 1 is less than or equal to k, which is less than negative 1.